break the chain. All right, so with that, we're going to go ahead and go to part B here, and this is example 2, part B. And so we're going to, again, like we did before, we're going to talk about figuring out what the transformations are. We're going to go ahead and find our vertical and horizontal asymptotes, if there are any, and then we're going to go ahead and graph it out to verify that a transformation that we said actually is happening here. All right, so with this, like I said before, we have different transformations happening. We have something going on there with the negative in front. We have something going on right here. So with that, how we're going to work this out is we're going to say, okay, we know it's going to flip about the x-axis of that negative. That's because of the negative in front again. Right? And so the other part is going to expand, or in some places you'll see where it says compress vertically. And so here I'm going to say expand, but again you can see the words compress vertically. So it's up to you, up to whatever book you read or whatever your teacher tells you to do there. And what I'm telling you is expand, but it means about the same thing. All right, so our vertical asymptote, let's go there, just like we did on the last problem. So we're going to do the denominator set equal to 0, so 2x equals 0. All right, and we get x equals 0. Okay, so not bad, we got that. All right, let's go to our horizontal asymptote really quick too. Find the variable with the highest exponent, divide everything by that variable with the highest exponent. All right, so we have the negative there, so we do 1 over x, and x is the variable with the highest exponent here. All right, so we get a negative 1 over x divided by 2. All right, we see here up top, when we any fraction we have left over, we're going to set it equal to 0, which we do. So negative 0 over 2. And you can't really have a negative 0. So here, it just gives us a 0. So y equals 0. All right, so when we graph this out, we should show that it actually has just flipped and then compressed, or vertically compressed, or expanded. All right, so our horizontal and vertical asymptotes. That's a vertical asymptote at x equals 0. Horizontal asymptote at y equals 0. So we have that. And then it says it flips. So if our regular parent graph looks like this, I'm going to do a dotted line for the regular parent graph. Ooh, that looks bad. If that's what we do for the parent graph, if we say we flip it about the x-axis, that means we should actually have it coming this way. And when we're saying that it expands, it means it's getting closer and closer to this line and closer to the x-axis, or the origin. So that's what we did there on these two spots. It got closer and closer to the x-axis there. All right, so with that, that's cool. All right, so let's go to example C, 2C. Oh, not B, not D. All right, so 2C. So we have the same thing we're going to do again. We're going to talk about the transformations, and we're going to go ahead and do all the vertical asymptote and everything. So here, if we look at this one, we have that it's a B down here. So that means it's a negative B, which means it should move right. And again, we're talking about B. And just as a refresher for anybody that's like a little confused or like, wait a minute, Mr. Hobbs, I'm lost. Remember, that's your B there. Remember, B goes left or right. So if it's opposite of what you think, it goes right, and it should go right. Sorry, forgot the number. Right, 3. All right. So here, that's what we have there. We have the 4 on top. So this one should compress it, or it should make it actually, some places you will see vertically stretch it. So I'm going to say, where's my pen? Another transformation here. We said it actually should shrink, or it could vertically stretch it. So with that, either one, it gives you the same process, same thought process there. All right, so here we're going to deal with our vertical asymptote and our horizontal asymptote. And also, let's do this. This is our B right here. This is our A. So that way we can look at that and anybody can go back and look. So for our vertical asymptote, set denominator equal to 0. We solve for x. So we're good on that. And then for our function here for the horizontal asymptote, we divide everything by the variable with the highest exponent. So that's x. Now here, don't get so comfortable that the only thing we're dealing with is x. For right now, that's the only thing we're dealing with. But don't get so comfortable that that's all it's going to be. Because at some point, we're going to change it and we're going to say x squared and x cubed. And we're going to say all these other stuff. So don't get focused and just like lackadaisical and get slothful because you're like, oh, this is going to be very easy. It's always going to be x. Not really. All right, so we found our horizontal asymptote here of y equals 0. And again, 4 over x, when everything's simplified down, 4 over x is still a fraction, so it goes to 0. 3 over x is still a fraction, it goes to 0. All right, so we get y equals 0. All right, so now let's go and take a look at the graph of it. I think I'm off a little bit with that first line. So let's fix that. Let's fix you. There we go. All right, so we're good there. All right, so now we said that we have a vertical asymptote of 3 and we have a horizontal asymptote of 0. So here, your vertical asymptote, 1, 2, 3, 4. So it's 3 right here. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, so we have vertical asymptote at 3. Let's do this in black. All right, you have a horizontal asymptote at 0. All right, so here we said everything should move 3 and it should compress or shrink. So that's what we're going to do here. And going back and thinking what I did when I said on the first video, actually when it's compressing, vertically expanding, that means it's moving away from the x-axis. When it's compressing, it's getting closer to the x-axis. So I think I said that right this time. I hope I did. All right, so that's example B, or example C. All right, and then let's go ahead and go to D. All right, so we have everything here. All the transformation, pretty much all the transformations are happening here. So this is a cool one. I like this part. So with this, let's go ahead and take a look at this and talk about the transformations and then move forward. So we have our B here, we have our A here, we have a flip going on, and we have C. We have C here, we have B here, we have A right here, and we have our negative. So it's a change for all of these, or a transformation for all of them. So with that, let's go ahead and take a look at it. So here, first off, let's go ahead and say we're going to go down 4. We're going to go to the left 2 for B. This is C. This is B. For A, we can say that either it shrinks or that it vertically stretches. And for what we talked about, we said shrink. But you can say vertically stretches too, pulls it. All right, and then the last one is actually flipping about the x-axis because we have a negative in front. Okay. All right, so just really quick again, when we say that it shrinks, that means it's pulling away from the x-axis, from the origin. And when it comes to expanding it, that means we're actually going away from the x-axis. So closer to the x-axis, sorry. Whoa. So if it shrinks, it means it's going away from it. If it expands, it means it's getting closer to the x-axis. So originally what I said, that was originally what I said. All right, so here we have all those transformations. Let's go ahead and find our vertical and horizontal asymptote. So we did this part here and we're good. So vertical asymptotes. So what I just last said, as it expands, it gets closer to the x-axis. If it shrinks, it means it's going away from the x-axis. So that's what I originally said, and I was right then. I was second guessing myself for some reason. I don't like that. Don't second guess yourself. Go with your first choice. All right, so vertical asymptote, we get x equals -2. All right, a horizontal asymptote. Our variable with the highest exponent is x. So with our fraction, like remember we said this is about fractions, not about the whole number, just the fractions. So we're dividing everything by x, which is the variable with the highest exponent. All right, so here, and let's do -4. Now again, we said with the fraction, we divide everything by that variable with the highest exponent, not the whole number. So that's why it's -4 by itself. All right, so here we simplify things down. You get a -6 over x over 1 plus 2 over x -4. And again, we talk about fractions. So again, this is not fraction. 4 is not the fraction. So you get negative, and you get 1 plus 0 here, -4. So this technically is 0 minus 4, which is -4. So our vertical asymptote, horizontal asymptote is y equals -4. All right, so we should have all this stuff going on. So the -4 moving in the actual, the y x equals 2 should match up with our transformations. And then we just have to do the flip and make sure that we actually shrink it, pulling it away from the x-axis, from the origin, sorry. Pulling it away from the origin, orange. All right, so with this part, let's go ahead and graph everything out. Hey there, Mr. Blue Skies. 1, 2, 3, 4, 5. Let's add some more up in here so it doesn't look so weird. All right, so -2, -4, -6. 1, 2, 3, 4, 5. So 2, 4. 1, 2, 3, 4, 5. So -4 here, -2. 1, 2, 3. So 2 there. All right, so we go ahead and put everything in. So we said we have vertical asymptote at x equals 2. Sorry, x equals -2. Vertical asymptote. All right, so then we have a horizontal asymptote at y equals -4. Horizontal. Ooh, that looks better. All right, so we said also that it's going to flip, and that it actually does the vertical stretch, or we say shrink. So here it flips, so that means it should be up here and here. So in these two areas, since the parent graph is the other way. So let's flip it, so we get this part here. And then it says it's shrinking, so we pull it away from the x-axis, or from the origin. Pull it away from the origin. And the origin would be where the two asymptotes meet. Oops, I didn't pull it away on this second one. Let's pull it away some. And just right now, just show us that it pulls away. All right, so that is it, guys. That's transformations, rational functions.